this section we go over three theorems that have situations where pieces get divided proportionally. So I will clarify as best I can what divided proportionally really means. On the screen is the official definition. I don't think that's particularly clear for students. That proportion really doesn't hit home what it really means. How about this? What if I told you that point L has been placed so that 25% of line segment AB is to the left of L, and 75% of line segment AB is to the right of L? Similarly, on line segment CD, point M has been placed so that the line segment has been split into 25% and 75% pieces. Since both line segment AB and line segment CD have been split into the same proportional pieces, they are said to be divided proportionally. It certainly doesn't mean that the 25% pieces are the same size. They clearly aren't. It's just that there is the same percent of the line segments on that side. That usually makes it much clearer for students exactly what it means to be divided proportionally. We cover three theorems this section, which end up with pieces that are divided proportionally. When things are divided proportionally, thanks to the properties of proportions we did in section 7.1, we have a lot of possible equations we can set up. It's actually kind of amazing that all of these things end up working out. In the official definition, the proportion they sent up went from left to right. AL over LB is equal to CM over MD. Great. We could also have worked from right to left. LB over AL equals MD over CM. We could have chosen to go top to bottom. AL over CM equals LB over MD. Another possibility is to use the full pieces. I could have put AL over the whole piece, AB, equal to CM over its whole piece, CD. Or how about LB over its whole piece is equal to MD over its whole piece? So many possibilities. Just make sure you always go in the same direction. For example, if you decided to go left to right with the first one, you better be going left to right with the next one. There's a lot of power when things are divided proportionally. As long as you put the same pieces over the same pieces and in the same order, almost any proportion you can think of will work. However, there's one thing not to do. Working horizontally or vertically is fine. Left to right works great. Up and down works perfectly. The one thing you can't do is cross. No making an X as you set up your proportion. For example, you can't go AL over MD equals CM over LB. Crossing like you would do with cross multiplication doesn't work. Stick to horizontal and vertical. Almost any proportion you set up that way will work. Now on to the three theorems which divide things proportionally. The first one has a great name, the side splitter theorem. That so doesn't sound like it came out of a math book. If a line is parallel to one side of a triangle and it intersects the other two sides, then it divides those sides proportionally. In the example picture at right, I do have a parallel line that qualifies. That parallel line happens to start at point B. In this picture, point B has been placed so that the left side of the triangle has been split up such that 60% of the side is above point B and 40% of the side is below point B. That parallel line goes from the left side of the triangle to the right side. It starts at B, which is 40% of the way up the triangle. By staying parallel to the base, it has gotten no closer and no farther away from the base. By the time it gets to the other side, the side splitter theorem says that the other side will be divided proportionally. So, point D must split the right side up so that 60% of the triangle is above and 40% of the triangle is below that point. The sides are divided proportionally. It doesn't matter what the actual percentages on the problem you are working with are. This theorem says they will match. Now, since these two sides of a triangle are divided proportionally, we have a lot of options for the proportions we might set up. We can work left to right. We might go top to bottom. We can put the top side over its whole side. Or how about the bottom piece over the whole side? So many possibilities. Just make sure you are going in the same direction and putting things in the same order. And a reminder, don't cross. This one doesn't work. Stick to horizontal and vertical. No crossing. The next one is a corollary to the last one. Remember, corollaries are theorems that directly come out of the conclusions from another theorem. If three parallel lines intersect two or more transversals, then the segments intercepted on the transversals are divided proportionally. So just to get the idea across of divided proportional one more time, this black transversal in between the parallel lines has been split so that 30% of the transversal is above the middle parallel line and 70% is below the middle parallel line. This theorem says that the other transversals are divided into the same size chunks. That's what this divided proportionally stuff means. Here's the same idea in a much smaller package. Just to reiterate one more time. Since these transversals are divided proportionally, you have a lot of options for the proportions you can set up. When facing problems using these divided proportional theorems, you may soon realize that one of the proportions fits the given information much better than the others and will be easier to use. All of them will work, but usually one or two of them are much easier than the others to use on a given problem. And lastly, we get to the last theorem, which is a little awkward to say, the triangle-angle-bisector theorem. If a ray bisects an angle of the triangle, then it divides the opposite side into two segments that are proportional to the other two sides of the triangle. Here is a triangle. This theorem needs one of the angles bisected, so let's do that. The angle bisector cuts the opposite side into these two pieces. Those two pieces are divided proportionally with the other two sides of the triangle. Since they are divided proportionally, you once again have lots of options for what to do. These two you should have been able to get. It's just working left to right and top to bottom. The ones where you use the full piece also work, but these are a bit more awkward with the triangle-angle-bisector theorem, since the y plus z part turns a bit. Y plus z isn't a straight line segment. It does still work, but probably not a popular way to go, or actually very useful in many problems that you will encounter because of that turn. Otherwise, it works just like the other divided proportionally theorems. Just work the same direction, horizontally or vertically, and whatever proportion you come up with will probably work.